In this lecture, we will learn about multithreading. In computer programming, a thread is an independent path that code can be executed on. Multithreading is when we use several of these threads so that we can run code simultaneously, also known as parallel execution of code. However, we do not need to keep all of the code running on the main thread. We have the ability to create a thread and then specify the code that we want to run on that thread. This code will run in parallel to the code being executed on the main thread. A thread is used to execute code, and it has access to resources and data within that thread. Each thread has its own call stack. It is not possible for code to be running without a thread. If you do not create your own threads, all of the code that you write runs on the main thread. Threading is considered an advanced Python programming topic, but it is an important topic for anyone hoping to become a professional developer. Python gives us the threading module to write code that works with threads. Before we dive into multithreading or working with multiple threads, let's look at a basic example of how we can create and start a thread. At the top of the program, we will import the threading module. Then we will create a function named function_for_thread, inside of which we will print hello to the console. Next, we will create a variable named t1 that we set equal to threading.thread. As an argument, we will pass in target equals function_for_thread. Finally, we will call t1.start. When we run the code, you will notice that hello is printed to the console. Now that we have experience working with one thread, let's look at a basic example of multithreading. Up at the top of the code, we will import the threading namespace. Then we will define a function named function_for_thread, but this time it will take in a parameter called num. Inside of this function, we will print num to the console. Then we will create a variable named t1 and set it equal to threading.thread. This function will take in two arguments. The target will be function_for_thread, and args will be an array with the number 1. The args parameter specified for a thread has to be an iterable, meaning a collection that can be iterated over. Then we will call t1.start to start thread 1. Next, we will create a variable named t2 and set it equal to threading.thread. We will pass in a target of function_for_thread as the first argument, and args equals a list containing a value of 2 as the second argument. Then we will call t2.start. Then we will create a variable named t3 and set it equal to threading.thread with a target of function_for_thread passed in as the first argument, and args equals an array with the value of 3 as the second argument. Then we will call t3.start. When we run the code, you will notice the values 1, 2, and 3 were printed to the console. Creating multiple threads by hand like this can be tedious and time-consuming if we want to work with many threads. Thankfully, Python gives us a way to automate the process of creating and starting threads. We do this by what is known as a thread pool executor. We can keep some of our existing code. We will delete everything aside from the function_for_thread function definition. Up at the top of the code, we need to import the concurrent.futures module. Then we will type with concurrent.futures.threadPoolExecutor and set max workers to 3, and then type as executor. Indented under this line, we will type executor.map and pass in function_for_thread as the first argument, and ranges 1 through 4 as the second argument. When we run the code, you will notice that it did the exact same thing. It created 3 threads, and each of them printed a number to the console. However, we did it in only a few lines of code this time, with much less effort. When 2 or more threads try to access the same shared resource, this can lead to problems. One common problem is known as a race condition. Since each thread is independent and has no idea if there are any other threads aside from itself, it just worries about its own code. A race condition can occur when 2 or more resources try to access the same piece of data or resource. For this next example, we are going to look at what happens if 2 threads try to update a database value. As you will see, this can be problematic. At the top of the code, we will import the concurrent.futures and time modules. Then we will define a database class. Inside of this class, we will implement the init function that takes in the self parameter. Inside of here, we will set self.value equal to 0. Then we will define a function named update that takes in 2 parameters, self and name. Inside of this function, we will print out which thread is starting the update. Then we will set local copy equal to self.value. Next, we will increment local copy by 1. After that, we will call time.sleep and pass in 0.1. Then we will set self.value to local copy. Finally, we will print out which thread is finishing the update. That's all the code we need to spoof a database update. Now let's write the thread code in Python. First, we will create a variable named database and set it to a database object. Next, we will print out testing update, starting value is, and then the database value. Next, we will type with concurrent.futures.threadPoolExecutor and pass in maxWorkers equals 2 as executor. Then we need a for loop for index in range 1, 3. Underneath here, we will call executor.submit and pass in database.update as the first argument and index as the second argument. Finally, we will print out testing update, ending value is, and then the value in the database. So we have two threads that are going to update this database value. What do you expect the result to be? Since each thread is updating the value by adding 1 to it, it should be 2, correct? Let's find out by running the code. As you can see, the ending value is 1. Why is this? Let's trace the code to find out. Thread 1 starts running. It adds 1 to its local copy. Then it sleeps. When it does that, thread 2 starts up and adds 1 to its local copy. Then it sleeps. Thread 1 picks back up where it left off, changing the value in the database to 1. Then thread 2 picks up where it left off. It thinks the database is currently holding a value of 0, which it remembers from before it went to sleep, and it knows nothing about thread 1, since threads execute independently. Therefore, it also updates the database value to 1. This is a real-world example of a race condition, where issues with code timing affect multiple threads trying to access the same resource. Now that we understand the problem, we need to work on a solution to ensure that the two threads don't step on each other's toes, so to speak. In Python, we solve this issue by using what is known as a lock. Only one thread can have a lock at any given time, and other threads have to wait their turn to use the lock. To fix the race condition in our current code, we only need to add 3 lines. Up at the top of the code, under our other import statements, we will import the threading module. Then inside of init, after we set self.value to 0, we will set self.lock to threading.lock. Finally, inside of update, we will add with self.lock, and then indent the code underneath it. Now when we run the code, you will notice that the database was updated to the correct value of 2. In the next lecture, we will look at a recap of what we learned in this section of the course.